Let me share my screen. Okay. Hello and welcome to the talk Adding Metaprogramming Support to Swift project. My name is Ivan. I'm a software engineer at Revolut. I have about 10 years of development experience with main focus on iOS mobile apps. Today, we're going to learn about metaprogramming in Swift. I will start with some basic introduction, then we will get practical. We will add metaprogramming support to an existing Xcode project, then we'll write some metacode, and then I will wrap up by outlining best practices for adopting metaprogramming in your project. So let's start with some introduction. So what's a metaprogramming? It's a technique in which a program has the ability to treat other programs as their data. In practice, it means writing code that generates other code for you. Now, what is it for? It's for minimizing the need for repetitive and routine tasks, and it helps developers to reduce development and maintenance time. It also helps us minimize human error, since the code is going to be generated for you. In practice, it means generating boilerplate code. Now, we already have some means in Swift for avoiding repetition. We have generics, we have extensions, we have inheritance, and those tools are great. But unfortunately, sometimes they're not enough, especially in cases when we need to provide functionality based on the list of stored properties of a struct, list of functions, or list of cases of an enum, etc. The classic example would be mocking a protocol. So you have your protocol defined here with these methods, and then you want to have a mocked version of it for your unit tests. So basically, we want to get access to the list of functions of this particular protocol, and then we will generate a mock using the very same list of functions. It's a classic example of metaprogramming. Many companies have adopted this, generating mocks based on protocols. So yeah, and you don't want to write this code manually. Hence, metaprogramming. Now, this is what your usual workflow looks like. If we add metaprogramming here, it will look like this. So we write some metacode, we send it to code generator along with handwritten code, and get some generated code as an output here. And both handwritten code and generated code goes to compiler. So in our case, this is in Swift and this is in Swift too. Now, speaking of what we have in Swift, Apple already provides us with some stuff. For instance, we have Mira, which is a native Swift object. It allows you to get inside a particular type to print its stored properties, etc. But it's very basic. It's usually used for diagnosis, just to print contents of your object. You can't do anything interesting like transformation and so on. Also, Apple publicly shared Swift syntax, which is a set of libraries for parsing, inspecting, and transforming Swift source code. But usually teams do not use Swift syntax directly, although it's a good instrument. People use Sorcery. Now, Sorcery is a code generator for Swift, which is built on top of Apple's Swift syntax. It extends the language abstractions to allow you to generate boilerplate code automatically. It's been adopted in more than 40,000 projects, including Revolut, where I work right now. It supports metacode in 3 languages: Swift, JavaScript, and Stencil. And also, it's a command line tool. It can run on demand manually when there's a change in code or template folders, and also on every Xcode build as a run script build phase. Okay. Now let's take a look at Xcode project. So here I have an example project, and we start by adding Sorcery to its port file. Just like this, save. And then we want to run pod install. Here we have our workspace generated for us, and we have added Sorcery as a dependency. Okay, let's open the project. Okay, so we have our pods and Sorcery as a dependency. Good. So the next step would be adding configuration file to your project. I will save me some time, and I will copy folder that I have already pre-set up. I will copy it in the root of the project. Now I'm going to add this folder to the project. Now I'm not going to add anything to the targets because this is meta code. We want it to live like that. Okay. So we have added a configuration file for Sorcery, and we have added a simple template. So let's take a look at configuration. Basically, here we define directory which we want to scan. In our case, it's this directory. We exclude Sorcery source/generated from our scan. And right now we want to use a single Swift template file, metacode. So this is a Swift template file. That's a very simple one, but it has some metacode. Okay, so we have added configuration for Sorcery to our project, and we have added a very basic template. Now the next step is to add a run script phase to our project. And let me copy the command. Right. So this is basically something that's going to run every time we build our project. So we executing Sorcery, which is located in pods directory, and we're passing a config to it, Sorcery ML, this config that we have just looked at. And the only thing is that we want to put this run script phase before we compile our sources. Okay, so that's done. Okay, so we have completed our very basic setup of the project. So let's take a look here. As config says, we will output something into source/generated. So right now we're in source folder. And when we build the project, it will create a generated folder and put something inside it. And what is it going to put here? Basically, it's going to put hello sorcery.swift file with this text, with hello sorcery. So let's press command build. And yeah, here we have our file generated for us, hello sorcery, generated by Sorcery 1.8.1. Okay, great. So since our configuration is set up to scan this directory source, let's make something more interesting. Let's change this Swift template file and print the list of all types that we have in our project. So let me copy command for this. Basically, this is where command in Swift begins. This is where it ends. So this is a regular code written in Swift that is executed by Sorcery. So we're going to get the list of all classes. Then we're going to take its names and then join them into a single string and separate using new line. So right now it's here, hello Sorcery. When I press command build, it's going to change to the list of files, list of classes that we have in our project. So that's very, very simple metacode, a Swift template that we have here. Now let's do something more interesting. But before that, let me briefly show you the project that we have here. So in the source folder, we have a bunch of view controllers, actually 5 of them. So when it comes to view controller, the most common operation after you create view controller is to either push it or present. And the thing is that some view controllers need parameters to operate. So before it's pushed or present, we need to initialize it properly. Some of view controllers don't need any parameters, right? And another difference between view controllers is that some of them are defined in storyboard and some of them are created programmatically. Now, these are basically two separate types of view controllers, and we have every possible combination here. So we have a view controller that's programmatic and has some parameters, programmatic that does not have any parameters, and view controller that is defined in storyboard and has some parameters, and another one that doesn't have any. So basically, what we want to do, we would like to generate extensions for navigation controller to push each of these view controllers, and if these view controllers have parameters, just forward them. So we don't want to write boilerplate code for pushing our view controllers, also for presenting them and creating. Now, basically, we have two conventions here that view controllers have to follow. So if it's a view controller that's defined in storyboard, it must conform to protocol storyboard instantiable. It just returns name of storyboard where this view controller is defined. That's one convention. The second convention, if view controller depends on some parameters, it must implement a function that's called initialize. So we have one here, and we have another there. So yeah, we have these view controllers in our project, and we want to generate some boilerplate code for that. So what I'm going to do, I'm going to replace this folder that I've just created for very simple Hello Sorcery Swift template with something more interesting. So let me do this. We don't need this for now, and we don't need this anymore. So we want to take that one. And we want to remove the old one from here, move to trash. And we want to add this one there. Okay. And again, when adding meta files, we're not adding them to the project because they're not compiled by Xcode. Okay. So here we have hold on. Here we're missing configuration file. Let me copy it from another place. So here it is, configuration. Okay. So here we have a different sorcery.yaml file, same directories to include and exclude, and also a bunch of Swift templates that we're going to use. So I guess let me first run the project to make sure that I have added everything correctly. Okay. Okay, the build succeeded. It means that in the source folder, we should have another generated folder, and yes, we have it here. That's great. So let me add this folder to the source directory too. This time we add it to the project. Okay, so let's take a look at what we have generated here. Let's start from the very end. So we have generated some extensions for navigation controller. So we have generated an extension that pushes autumn view controller, spring view controller, summer view controller, and winter view controller. Basically, the templates that are defined here, they have scanned for view controllers identified them and created extension for navigation controller, and also they have captured all the parameters. So for instance, if we take a look at autumn view controller, we see that its initialize method has parameters like everyday rain, yes, no, and also leaf amount, whatever it means. And the function for pushing it onto navigation stack has the exact same parameters. So we made an extension for navigation controller to push screens, and we made another extension for view controller to present them. And again, the list of parameters is preserved. So this code has been generated for us. And again, those are like four different types of view controllers: with parameters, without parameters, programmatic, and defined in storyboard. Okay. Now let's take a look how we're going to use this code on the call side, and then we'll get into the template. So at the root of everything, we have this main view controller, and let me show it to you. Let me run the project. Okay, so this is the main view controller, and it's like the central hub for launching all other UI. So we have a section that defines parameters for Spring View Controller. Spring View Controller accepts two parameters, the speed of wind and also flower name, and it's a programmatic view controller. We have another controller with parameters, but this one is defined in storyboard. It has these parameters. So basically, when we tap on these buttons, we're going to call methods that we have just generated. These methods will instantiate view controller for you, whether it's programmatic or defined in storyboard, and then initialize it with the required parameters if this view controller has defined the initialize function. Now let's take a look at this on the call side. So let me uncomment these lines. I have to comment it because before we had this code generated, we couldn't call these functions, and we would have compilation errors. So basically, let me rerun the program for you. So yeah, we have just presented a view controller using code that we have generated, and we're passing width speed. Let's make it 100. So yeah, 100%. Leaf amount, I want maximum. So this view controller, auto view controller, expects two parameters: Boolean everyday rain and then leaf amount. Everyday rain set to no, leaf amount maximum, can be minimum, whatever. Okay, good. Now, why did we have done this in the first place? The thing is that if you have a big project, like really big project, the amount of screens will be huge. And you need to change the parameters of a particular screen quite often. And when you do this, you will need not only to change the parameters of the view controller itself, but also of all extensions, extension for pushing it, extension for presenting it, and so on. So for instance, here Spring View Controller accepts two parameters. Now, when we presenting it, our function has these two parameters that it forwards to function that creates this view controller and then presents. So what we want to do, we want to be able to regenerate all boilerplate code when we add something here. So let me add a third parameter here, like param3, whatever it is, make it bool. When I will press Command B, it will run the Sorcery template first, and it will change this code here. So let's take a look at Spring View Controller for presenting it. Spring View Controller has these parameters now. When I press Command B, it will add this new parameter that I just added. Now we have this error here because on the call side, they expect us to provide this extra parameter. But yeah, all the boilerplate code has been regenerated instantly. So code for presenting view controller now has another parameter. Code for pushing it has another parameter, and obviously code for creating it. And seems like not much, but when you have a big project with many screens, this is going to save you a lot of time. Now, yeah, let's do something else to show how the system reacts. For instance, let's define another view controller. Let's call it like full year controller. And again, we have just added another type to our system that inherits from UI view controller. So when I press Command B, it will generate method for this new type. So here we have full UI view controller now too, in create, present, and push. So yeah, now let's go finally through the template. Once we understand how the system works and what is it for, let's take a look at the template. So we've already seen the configuration. It has separate templates for each helper method. Now here we have let's take a look, for instance, at this one. So this is Swift template for generating helper functions for presenting view controllers. In Sorcery, you can include other Swift files into your file. This is how you reuse code. So basically, here we're including some common stuff that's defined here, some helper methods. And the main code for this template is written here. Now, basically, this is how we output something into this file here, that one. The whole code is defined here, and I prefer to define it in a .swift file because this is how you get syntax highlight and everything nice. Because with Swift template, it's just boring code, no autocomplete, nothing helpful. So basically, this is a method, single method that's used that renders text here. Let's take a look at it. So generate output is defined here. Basically, we provide an extension for your view controller, then some helper methods, and then for each view controller that's defined in our project, we generate present methods. Now, again, this is code in metacode, and this is that code here when it's being generated. Okay, generate present methods looks like this. Basically, we're getting types that we want to be processed. We're getting a list of view controllers, and then we generate those methods. Now, this function is defined here. Basically, we're getting access to all types.classes that are in our project, and then we filter and leave only those that inherit from UI view controller or UI tab bar controller, and those that are not generic because we're not supporting generics. Okay, so we're getting the list of our view controllers, and then for each of them, we generate the method. This is the function. Basically, the function name is generated based on the view controller name, function parameters, if they're there or not, and function body is quite trivial. It's basically view controller, present, and then here we instantiate our view controller. So as you can see, this Swift template is quite simple, basically iterating through types and then generate for each type something. So they're all quite similar. The one for present and the one for push. The difference here is that push method are provided as extension for UI navigation controller. So yeah, that's basically it. Yeah, source, meta, and these folders. So let's get back to the slides. Done with it. Best practices for adopting metaprogramming in your project. Rules of thumb for metacode. Basically, you want to apply the same rules to generated code that are considered good practice for handwritten code. Follow single responsibility principle. Stay close to Apple's naming and signature. Follow Apple's API design guidelines. Follow any practice that you're happy with. Also, you want to make a generated code readable by reducing LOC. So you want to use init instead of type name, self instead of type name, skip those if it's possible, skip return if possible. The thing is that although we generate our code, human will still read it from time to time. So we want to make this job easier for them. And also you want to reuse generated code inside other parts of your code. Like when you start generating code, the cost of creating it is close to zero, right? You can generate whatever code you want. And it might be tempting to leave some code duplication there because who cares if you can regenerate it fast? But still, you want to make it as good as code that's written by hand. So try reusing as much as you can, even inside generated code. As for code generation pipeline, as you saw, the generated code featured minimum formatting. So I had coded for spaces, indentation. I used symmetric brackets, which might be a bit controversial for Swift community. But the main idea is that I would like to separate code generation from code formatting. And if you want your generated code to comply with a certain style guide, use a dedicated formatting utility for that. Luckily for us, we have Swift Format. This is another tool, a library for reformatting Swift code. It's a command line tool that can be run on demand or on every Xcode build as a run script phase. It features about 90 formatting rules, and it can help you with adjusting white spaces, removing redundant selves, type names, parentheses, and it can even use a header template for all of your source files, so they all look consistent. Now, this is how code generation pipeline looks just with code generator. So we have our handwritten code, metacode, sorcery, and generated code. You've seen it just in the example. And if we want to add some formatting, it basically will look like this. So after we get generated code, we then forward it to formatting utility and get formatted code to whatever style guide we want. So yeah, it's important to separate those stages and make sure that each utility does what it does best. Okay, more examples of metaprogramming applications. So here, basically, I'm going to share with you some ideas how you can improve your workflows and utilize it. I've already discussed this. Metaprogramming is probably used most for generating mocks. So when you have your protocol and it has these methods, we can generate a mock version of it. By the way, Sorcery repository features a template for generating mocks for your protocol. It's called AutoMockable. It's great. Everyone uses it, so you should be using it too. These mocks will be later used in unit tests to make sure that system under test reacts correctly to defined mock behavior. Speaking of unit tests, you also want to use metaprogramming for generating samples. Now, when you have a simple data structure like this, album with ID, title, and release date, you want to generate this function based on this data type. So this static function creates for you a sample that you can use in your unit tests. It provides default values for every stored property of the structure. And if you want, you can obviously override any of them. So for instance, if you want to write a test that makes sure that albums are sorted alphabetically, you create a sample and you just define title for it, title A and title B, right? All other values are provided for you. If you write another test and you want to make sure that albums are sorted according to their release date, well, you provide only release date for the sample function and everything else will stay by default. So it's really useful because it makes your unit test code shorter. You just define what you need for this particular test. It's easier to read. Now, you can also use metaprogramming for times when you deal with functions that, like a family of functions that look really similar one to another, and the difference is only in the number of parameters. So let me be concrete here. So I'll give you an example. It's called partial application, a process of fixing number of arguments to a function, producing another function of smaller arity. Arity is basically a number of arguments that function takes. Let me give you an example. So a function that reduces arity of another function is called bind left in that case. It takes a function that accepts two arguments and returns a function that accepts only one argument, and it fixes one of them. So basically, you provide a function, you provide value for the first parameter, and this first parameter goes here, and only this one will be changed in runtime. So here we're changing arity from 2 to 1. Now, there is also another version of this function that accepts a function of 3 arguments, arity 3, and returns another function of arity 2 from 3 to 2. And another function that accepts function of 4 arguments and returns function of 3 arguments. So basically, you get the idea. Those functions are really similar one to another. The only difference is the number of generic arguments. And you don't want to write this code manually because it's quite boring and repetitive. So if you don't want to write this code, just don't, and use Sorcery instead of it, right? Write a template that just generates you as many versions of bind left as you want. Not to mention there also is bind right that fixes argument from the right of the argument list. So yeah, when you need to deal with functions, family functions with different arity, use metaprogramming. It will save you some time. Now, that's a very interesting example, and you can actually try it. It's been provided by the author of Sorcery, Krzysztof Zabłocki. Basically, if you define a structure with stored properties, whatever properties you want, like string or some enum, it can generate for you a screen where you can edit those values. So basically, you just define your data structure, you provide default values, and then template generates a screen for you, a whole full screen where you can edit values, store them, and get notified when they're updated. So it's very, very powerful. If you want to change something, just add one line of code, another parameter, and the screen will be regenerated. So basically, those are examples that I find particularly interesting. And yeah, but what to generate if you have your own project? My advice would be first identify the problem and then write metacode. Like in my example with view controllers and boilerplate code for navigation controllers and so on, it really bothered me that in a project with about 60 screens, we had to make all these changes. So in the end, I wrote this template, and it saved the team a lot of time. So the whole approach here should be similar to performance optimization. When you do performance optimization, you don't optimize everything. You find the spot that's the most problematic and you fix it. So same with metaprogramming. Prioritize those things that bring maximum value. Like in my case, it was this thing with boilerplate code. And also, you should be creative when identifying repetitive tasks. You should train yourself to look for patterns everywhere. And I guess last piece of advice is about sharing this metacode across projects. This is the structure of project that you just saw. So we have source folder that has all the source, both handwritten and generated. And we have another folder with meta stuff. So we have Sorcery configuration, which is project specific. And we also have templates. And these templates, they can be shared. So basically, how do we share these templates across the multiple projects? So my answer to this is using Git submodules. Basically, Git submodule is another repository. So you create a repository where you put all of your templates code. And then in this current repository, you save a reference to a commit in another repository. So all of your project can reference this another repository where templates are stored. And they can use whatever templates they want to use, and configuration will be project specific, defined in the project of every repository. Yeah, so this example with view controllers, pushing and presenting them, is been described in more detail in my article that you see on the screen right now. So go and take a look. It also features all the source code that we saw today. And I also have written another 2 articles recently. They are about adding union data structure to Swift with metaprogramming. So I also provide all source code for this. You can run it in Xcode's playground, or you can even run it on REPL.it, so you don't need to download anything. And I guess that's all I have to say today. So I'm happy to answer any questions. If we have any. Hello, Jose.
Oh, did you hear me?
Yeah, I can hear you. Hi.
Oh,
Nice
hi.
to meet you.
I just have one question. When
Mm,
you when you talk about the big projects, really big projects, and you need to build the project from scratch, like when I started in SCI to deliver to production.
mhm.
I have anything I need to build from scratch.
Right.
Did you see any impact on build time when you need to regenerate from scratch the entire code for this project?
Yeah, that's a very good question. So um, the build time really depends on Sorcery, right? So back in the day when I used this set of templates, I've been using just one very big project, and yeah, sometimes it was not very speedy. And I really considered sometimes just disabling this script that runs every time. That's one thing. Now, in my latest project, I have a bit different structure. So it's a huge mono repository with a bunch of shared modules. So
Mm-hmm.
each shared module operates like a small project. So you usually have a small app for any module, and usually developers live in this small project. So there you can basically enable it all the time. It works okay. When you need to take, I don't know, 20 of your modules, 50 of your modules, and build the super app, you just do it, and you're not generating any source code there. So yeah, but yeah, that's a valid question. For instance, I know that some teams they do not use run Xcode build phase. They just use command line tool. When they know that they have made some changes, they just run it on demand, and it works for them. Uh, I think it's reasonable when you're, for instance, generating mocks based on your
Mm-hmm.
protocols. Change something, generate it once, then you write your unit tests. In my case, with view controllers and everything, it was more dynamic. So I changed view
Mm-hmm.
controller list of parameters, and then I wanted it to be reflected in all those boilerplate code automatically. And one important thing that I didn't mention, obviously, passing parameters to view controller is not a good architecture, right? Because it's not testable. You want to have your view models, want to have your presenters, coordinators, whatever thing you use, Viper, blah
Mm-hmm.
blah. I just use this very simple to not overcomplicate example, because I think it's already too complicated, right? So I didn't want to introduce like some custom architecture that the listener would need to understand. So yeah,
Oh, nice. It's a very powerful tool. When you talk, I think a lot of problems that you have here
right.
on my company that I can resolve this. But I just think about the build time. I will test about it. But thank you for this talk. It's a really powerful tool.
Yeah, no worries, I agree. And also, as for like type of task that you want to do, like I would say that we can give 2 classes of them. So first class is when you need to scan your project. Like in my example, I'm getting a list of view controllers, and then I generate something based on them. This is one thing. And
Mm-hmm.
second thing is when you don't need any input data, like with partial application and bind left. You just want to generate a bunch of functions. You don't need any input from the outside of world.
Mm-hmm.
So my second set of articles about union is about exactly this thing. So union basically is a data structure which is either this type or that type. So it's type A or type B, or
Hmm.
type A, type B, type C. So I generated the family of these unions using Sorcery. So yeah.
Yeah, nice. I will try to implement that. Use the mocks. The mocks is as I said, we generate an entire list of files just to make the mock, and every time I need to edit that. So it will be my first task to use that.
Yeah, obviously I agree. Yeah. Again, if you're using like a mono project, which getting bigger and bigger, it's not a good idea, right? If
Hmm.
every team lives in its own small project, it's probably okay-ish, right?
Yeah,
So yeah, because
I
like
agree.
if you have good modularization, you'll be safer in that regard.
Nice.
So yeah.
So for my part, that's it. So thanks again for this talk.
Yeah, no worries. Thanks for joining and for listening to it. I hope it was helpful.
Yes, it's a lot, and
Yeah.
I expect other ones. So please share with me if you do any other talks, and I will be there.
Yeah, sure. Thanks. So if I think you can follow people on Codementor if you
Yeah,
find my profile and subscribe to it. I guess next time I give something, you'll be notified. So yeah, Jose, thanks again for joining. Appreciate that.
for sure. Thanks. Bye
Have
bye.
a good- Bye.